Today we're going to do something pretty cool. We're going to take two totally separate digital worlds, two computer networks that right now can't talk to each other at all, and we're going to build a bridge between them so they can have one single conversation. Let's dive right in. You ever stop and think about it? You hit send on an email, you pull up a website, and it all just happens, instantly. It feels like magic. But underneath that, your data is going on this incredible little journey. So what's actually happening to get your message from point A to point B, especially when they aren't even on the same team? To pull back that curtain, we're going to build a simple network ourselves. And here's our blueprint for today. We've got a network on the left, another on the right, and sitting right there in the middle, acting as the bridge, is one single router. The mission? It's simple. Make PCA on the left talk to PCB way over on the right. And right away we hit our first big problem. The connectivity challenge. Because right now, these two networks are like two totally separate neighborhoods on opposite sides of town. People in one have absolutely no idea the other one even exists. So, first things first, we need to give them a map. Okay, so here's the absolute #1 rule of networking. Every single device, from your phone to your PC, needs its own unique identifier. We call this its IP address. And the analogy here is just perfect. It's a postal address for your computer. Without one, data would just be lost mail, floating around with nowhere to go. But just having an address isn't quite enough. How does your computer know who's a neighbor on the same street versus someone all the way across town? Well, that's the job of the subnet mask. It's the thing that draws a line in the sand and tells your PC, hey, this part of the address is your street name, and this part is the specific house number. So this whole idea of streets and neighborhoods, it leads us right into the planning stage. See, before we can just start plugging things in and hoping for the best, we have to actually sit down and design these digital neighborhoods. And there's a name for that process. It's called subnetting.
Okay, this is where it gets really clever. We start with one big plot of digital land, right? One big network. But we need 4 smaller, more organized ones. So what do? We borrow 2 tiny little bits from the part of the address meant for devices. And with just those 2 bits, we can create 4 separate subnets. Because 2 to the power of 2 is 4. This little bit of math gives us our new subnet mask and this magic number, our block size of 64. Trust me, that number is everything.
And with that block size of 64, check this out. We can just lay out our plan. Network 1 starts at .0. The next one, just add 64, so it starts at .64. Then .128, and so on. It's super clean. Now for what we're doing today, we only need the first 2 networks from this plan, but you can see how this gives us a really organized system. Okay, enough planning, the blueprints are done, now it's time to roll up our sleeves and actually build this thing. Virtually, of course. So for any PC, any device at all, to get online, it needs to know the answers to 3 fundamental questions. It's like its digital identity. First, who am I? That's the IP address. Second, where am I? That's the subnet mask, its neighborhood. And third, and this one is so important, how do I get out of here? That's the default gateway. Let's look at PCA. To set it up, we literally just plug in those 3 pieces of info. We give it its name, 192.168.0.100. We tell it what neighborhood it's in with the mask, and then we give it the address for the exit door, the gateway, which is 192.168.0.1. So we keep talking about this gateway, this exit door. Well, what is it? It's the router. The router is our post office. It's the one device that has a foot in both neighborhoods. Its entire job, all day long, is to look at the address on a piece of data and say, oh, you're going to that other street? Let me forward you over there. And how do we talk to the router and tell it what to do? We use the command line interface, the CLI. Yeah, there are point-and-click ways to do this, but for real network pros, the command line is where the magic happens. I mean, these are the exact skills that certifications like the CCNA are built on, knowing how to speak the language of the network directly. So check this out. We go into a specific port on the router, we assign it that gateway IP address we talked about, and then we type no shutdown. In that command, it's literally like flipping a power switch. You hit enter, and that connection just lights right up. And then we just rinse and repeat for the other side. We jump into the router's other port, the one connected to our second network, and we give it the gateway address for that neighborhood. No shutdown, bam! Now our router has an active working connection to both of our separate worlds. The bridge is built. All right, The planning's done, the configuration's in, everything's set up. This is it, the moment of truth. Let's run a test and see if this whole thing actually works. So, the big question is staring us right in the face. Did we do it? Can a message from PCA actually cross that bridge, go through our router, and find its way to PCB in a totally different digital world? Well, there's one really simple way to find out.
We're going to go to PCA's command prompt and use one of the most famous network commands ever, ping. We're basically telling it, hey, send a little hello packet over to PCB. And that little packet is about to go on an epic journey from the PC to its switch, up to the gateway router, across the bridge to the other network, and hopefully land on PCB's doorstep.
And look at that! A reply. PCB is talking back. That little line of text is everything. It's proof. It means our message got there and a reply came all the way back. We have end-to-end connectivity. Our two worlds are officially having a conversation. Success! Now that's pretty cool, right? But here's what's really mind-blowing. Everything we just did in our tiny little two-network lab, those exact same principles are what make the entire global internet work. I mean, just look at this. Our little lab uses IP addresses. The internet? Same thing. We used one router to forward packets. The internet uses millions and millions of them. We connected two networks. The internet connects billions. It's the exact same idea, just on a scale that's almost impossible to imagine. And that leaves us with this one last kind of crazy thought. If a router only knew about its two little neighborhoods, and every single router on the entire internet only knows about its own immediate neighbors, who's in charge? If everyone's just looking at their own little local map, how does a packet get from here to halfway across the world? Who's running the show? Sun to chew on, isn't it? Thanks for joining me.